Welcome to a Fourier series example. So recall for a function f, on the interval negative L to L, the Fourier series is the function capital F of x is equal to a naught plus the sum from n equals 1 to infinity of a sub n times cosine n pi over Lx plus b sub n times sine n pi over Lx, where a naught is 1 over 2L times the definite integral from negative L to L of our original f of x dx. A n is 1 over L times the definite integral from negative L to L of f of x times cosine n pi over L x dx. And our b sub n are 1 over L times the definite integral from negative L to L, f of x sine of n pi over Lx dx. So let's go ahead and do an example. Let's find the Fourier series on negative 5 to 5 for the piecewise function, which is 0 between negative 5 and 0, and 2 between 0 and 5. So again, our capital F of x should be equal to a naught plus the sum from n equals 1 to infinity of a sub n times cosine of n pi over Lx plus b sub n times sine of n pi over Lx. Our job is to then calculate these coefficients. So our a naught is equal to 1 over 2L times the definite integral from negative L to L of f of x dx. Here our L is 5. Again, we're going from negative L to L. Our L is 5. So a naught is 1 over 2 times 5 times the definite integral from negative 5 to 5 of f of x dx. This is 1 over 2 times 5 times the definite integral from negative 5 to 5 of 0 dx plus the definite integral, from negative 5 to 0 of 0 dx plus the definite integral from 0 to 5 of 2 dx. This is 1 over 10 times, this would just be 0 plus, and then we would do 2x evaluated at 0 and 5. We wind up just getting that this is equal to 1. So we get a naught is simply 1. For the remaining a sub n, we are looking at 1 over L times the definite integral from negative L to L of f of x times cosine n pi over Lx dx. Again, L is 5, so we have 1 over 5 times the definite integral from negative 5 to 5 of f of x times cosine of n pi over 5x dx. But f is 0 from negative 5 to 0. sorry, for -5 less than or equal to x less than or equal to 0. And so we wind up that this is just 1/5 times the definite interval from 0 to 5 of 2 times cosine n pi over 5x dx. Or 2/5 times cosine, we would go to 5 over n pi, and sine of n pi over 5x, evaluated at 0 and 5. So we are looking at 2 over n pi times, we would have sine of n pi minus sine of 0. And this is, of course, just equal to 0. So we have all of our a sub n's are equal to 0. Finally, our b sub n's, we are looking at 1 over L times the definite interval from -L to L of f of x times sine of n pi over Lx dx. Again, L is 5. So we are looking at 1/5 times the definite interval from -5 to 5 of f of x times sine of n pi over 5x dx. Once again, our f is 0 for -5 less than or equal to x less than or equal to 0. And so we wind up getting that this is 1/5 times the definite interval from 0 to 5, and then f is 2 elsewhere. So of 2 times sine of n pi over 5x dx. This becomes 2/5. And then inside we would have a -5 over n pi cosine of n pi over 5x. And we are evaluating at 0 and 5. So we are looking at 2/5 times, we have a -5 over n pi cosine of n pi minus -5 over n pi cosine of 0. Now for your odd integer multiples of pi, we would be looking at -1. For your even integer multiples of pi, cosine is +1. So cosine of n pi, we are actually looking at, so we'll have 2/5 times -5 over n pi. Cosine of n pi is actually just -1 to the n. Right? For those even integer multiples of pi, cosine is +1. For odd integer multiples of pi, cosine is -1. So we have cosine of n pi is actually just -1 to the n. Then we have plus 5 over n pi at the end. So I'm going to split this into 2 cases. For n even, we are looking at 2/5 times -5 over n pi plus 5 over n pi, which is just 0. For n odd, we are looking at 2/5 times 5 over n pi, -5 over n pi times -1, plus 5 over n pi. And this is 2/5 times 10 over n pi, otherwise known as 4 over n pi. So what we get then is that b sub n is equal to 0 for n even, and 4 over n pi for n odd. So what we get then is we can write our series as our capital F of x is equal to, our a sub n was equal to 4. Sorry, our a sub 0 was equal to, not 4. A sub 0 was equal to 1. Then we have plus the sum of, for n odd, we will have 4 over n pi. So this is n odd, n equaling 1 to infinity. 4 over n pi times sine of n pi over L, so n pi over 5x. Or equivalently, we get f of x is equal to 1 plus the sum from n equals 1 to infinity of 4 over 2n minus 1 times pi. 2n minus 1 times pi all in the denominator there. Then multiplying sine of 2n minus 1 times pi all over 5, and then times x. So this would be our final version, sort of condensed version of writing our Fourier series for the function that is 0 from -5 to 0, and then 2 from 0 to 5. In the next video, we will go ahead and look at sort of precisely where this function matches our original function and where we have slight discrepancies.